We're going to continue with our revision still on paper 3, still on topic measurement regarding the analysis of the graph. But today we are going to discuss the question from SPMRSM 2017 paper 3. So let's read the question. The student carries out an experiment to investigate the relationship between the depth of a wooden block immersed in liquid and the mass of slotted weight placed on the wooden block. So the depth is actually the RV, the mass is the MV. The result of the experiment are shown in the graph of H against M. So again, H against M, H is the RV, M is the MV on page 9. So let's look at that first. So this is the graph. So H against M, H is the RV, M is the MV, RV, the unit is meter, and the MV is kilogram. The unit is, the MV is the mass, M, the unit is kilogram. So when we look at the graph, we see that it touches the point 0 here. That means it is directly proportional. So that is the first answer, should be the first answer. Based on the graph in diagram 2.1, state the relationship between H and M. H is directly proportional to M. Doesn't need you to write in full, such as the H is actually the depth, right? So you don't need to write that, you just write the symbols. So number 2, determine the value of H when M is 0.20 kilogram. So on the graph, how you determine the value of H. So basically this is interpolation. So it's given us the X values. Ask us to find the Y value. Make sure that you show the dotted line on the graph. So let's do that. So 0.5, right? 0.2, sorry, 0.20. Okay, the x-axis, 0.2, dotted line. And then until touches the y-axis. So let's count how many. Basically, this is 10 units, 0.001. So this is 0.021. This is 0.022. So 0.022. .022 meter. And that should make sense because we are in the meter, which is quite large, the unit. So the number will be smaller. So the marks, one mark for the dotted line, the interpolation, another one mark for the correct answer with the correct unit. So number 3, calculate the gradient K of the graph. Show on the graph how you calculate K. So again, you must make the requirement, the triangle requirement, the minimum size, which is 8 cm times 8 cm. But my tips is you just use the whole graph. It should be exceed the requirements, the minimum requirements. So this is my triangle. So make sure that you draw your dotted lines clearly, but in the exam you don't need to worry because this graph paper will be in blue color. So your pencil, 2B pencil should be enough. 0.0, level the coordinates. This should be 0.7, 0.08. 0.7, 0.08. Okay. 0.7, 0.08. So the unit is, this is meter, this is kilogram. So plug in that in calculator. 0.1143 mkg negative 1. So you don't need to put all the 4 decimal place, at least 2. So the unit is basically from the gradient. Wait, that is not 0.08. I'm sorry. This is slightly 0.08. So this is 0.78. 0.7, 0.078. Okay, so let's redo. Okay, let's redo our gradient here. So this is the importance for you to pay attention to details. Because it might causes you to lose mark. Okay. So the answer is not that different. Again, at least 2 decimal place. Now let's move on to the next question. The density of the liquid rho is given by the formula as shown, where A is the cross-sectional area of the wooden block with the value of 4.0 times 10 to the power of negative 3 meter square using the formula and the value of K. Into A3, calculate the value of rho. So we don't need to rearrange the formula, we just use as it is. But here it asks us to use this value here, which is the A, and this value here, K. But K is not shown in the formula, right? So where should the K be? So that is a simple thing to do. You just need to think about the K symbol in terms of the units in the graph, on the graph. So y divided by x, right? So y is actually h. The x-axis is actually m. So we need to find this combination inside this formula. Again, we don't need to rearrange. We just need to compare these two. So if you can see here, this one is h over m. This is the gradient that we calculated before. But in the formula is m over h. So it's little bit inverse. The formula is flip the top and bottom, m and h. So what we should do, we don't need to adjust the formula. What we need to adjust is the gradient. So basically, how we're gonna flip the top and bottom? We just make it 1 over k. So if 1 over k, then it becomes m over h. So now we just need to plug in that into the rho. So rho equal to m a h equal to 1 over a m over h. So I factorize 1 over a out and left with m over h. And then we know that m over h is actually 1 over k. 1 over k. And then we just plug in the value for a and negative 3 meters square. Don't forget the unit because we might have a different style of unit here. The k is that we calculated before, 0.1114 mkg negative 1. So plug in that into calculator. You will get 2243.59. 2 decimal places is enough. And the unit should be kg m negative 3. So you are safe here because it given us the unit already. We don't need to find it from the formula. But if you want, you can. Because this one here, because m squared is in the bottom, it becomes m negative 2. This one m is also on the bottom, multiplied by m2, become m negative 3. And then kg negative 1, already in the bottom, so it will be cancel out the negative. So it becomes kg m negative 3. So which is the unit of the density. So it has 3 marks here where it goes. First one is this one. This one, the second one, and then this one is the third one. Okay. So let's move on. The relationship between buoyant force FB and the density of the liquid row is given by this formula. Using the answer in 2B, calculate the buoyant force when the volume is this and the acceleration due to gravity is this. So again, it asks us to use the formula and the value before to find the buoyant force here. So basically, we don't need to rearrange the formula. It's already in the correct order. So we just need to plug in all the values. The density value is what we found before. 2243.59 kg m negative 3. Make sure that you write the unit because we might end up with different unit. And G is given 10 Newton per kilogram. And V is 5.0 times 10 to the power of negative 4 meter cube. So the meter cube will be cancelled out, the kilogram also be cancelled out, so we just left with Newton. So that should be our final unit. So plug in that all numbers into the calculator. We should get 11.22 Newton. Okay, make sure that you write the 11 correctly. Okay, that is the answer, the unit with the correct unit. So this is 1 mark, the calculation, and then the answer with the correct unit, 1 mark. Lastly, state 1 precaution that should be taken to improve the results of this experiment. Again, we're going to use the template that we already done before. Make sure that your eyes are perpendicular to the reading scale. So what are the measuring instruments used in this experiment? Basically, the y-axis is in meter, the x-axis in kilogram. So you can do either both, but I want to use the easiest one, the obvious one, which is the meter. We use meter rule. Meter rule. And then forget to add to avoid parallax error. So this sentence over here is usually omitted, so it's not correct. You must include all the points. So that's all for today, and this time is quite easy except for the formula that involve the gradient. You need to use your mathematical expertise here in what you learn during your math in lower form to manipulate the variables, to exchange the places and do some kind of creative ways to find the gradient inside the formula given. Again, that should be simple enough. It doesn't need you to do square root or cube root or anything fancy, just multiplication and division. You should understand and recognize it from the formula. So that's all for me from today. We're still going to continue with this paper 3 until we're confident enough. Thank you.